So, hello everyone. Today I would like to talk to you about quite interesting topic, and that will be the topic of load balancing. You may or may not have heard of this, but of course, when at the end of the development of your software, when we've done talking about backend and front end, and we have this, of course, serving customers, like you can think of like really big companies like Facebook, for example, serving customers all around the world, you can already imagine that it goes beyond writing the actual code that runs on the back end and the front end. You would need to serve this application to people around the world. And of course, with unpredictable load coming from different parts of the world at different times of the day, because if it is morning in the US, it might be night in Asia or something like that. And so a crucial aspect of managing like these huge applications will be the concept of load balancing, where you have a fleet of servers that have to manage incoming requests. And these have to, of course, uh, manage these requests in such a way that they don't crash. So you would like to encompass for load, and of course you would like to encompass for to make sure that the user don't, of course, experience latency in their requests. And so that's why I would really want to talk to you about today about load balance. And of course, this is really, really not something normally you would have to bother about if, at least if you are like a core developer. If you're not like a DevOps, for example, or doing SRE, this is mostly something you probably never have to worry about. But I think it's a really cool topic that I think it's also worthwhile for you to hear about it, and of course maybe understand a little bit how it works under the hood. And I have a picture over here, as you can see, which I just took out of the internet. But it's the whole concept is pretty clear. You have a fleet of clients trying to connect to your application over the internet, and you have, of course, on the other end, a fleet of servers. And what happens is that when you have these incoming requests, you would want to distribute these to your servers, and you don't just want to. Let's say you have 10 servers and 10 requests comes in, and each of your servers gets one. You would really like to have like a robust logic under the hood that correctly distributes this logic to your servers. You don't want to put more load on a server that is already busy when there is a server which happens to be free. So that's really the concept. And to do this, of course, there are a lot of ingenious ways that people have devised over the years, a lot of cool algorithms that people have come up with over the years to kind of like handle how this distribution occurs. These are some of the things I'll talk to you about today. And of course, to make a little bit more sense, we have to implement ours. It's going to be a really dummy one, but yeah, we would begin to understand how this works under the hood. So let's jump right in and start writing some code actually. But first, of course, we'll have to talk a little bit more about this. So normally you would never have to implement your load balance. That's just the simple truth. Of course, you would not have to. There is no need to reinvent the wheel when there are all you have to do more or less is to walk on the shoulders of giants who've come before you. So, but we would want to do this to kind of like give us an intimate understanding of really what's people, for example, who are into systems engineering or systems development actually do under the hood. And again, we maybe begin to appreciate the work they do actually. So when it comes to load balancing, of course, there are some key things I think it makes a lot of sense for us to understand in the first place. Which this will of course give us the premise of our conversation today, so that we can really drive it home, right? So the whole point is that with load balancing, more or less, we kind of like it ensures efficient resource utilization. We don't want to have idle servers and servers that are way too busy than they should be. We want to, of course, achieve high availability, and we want to be able to scale. So we also don't want to have 100 servers running, let's say, when if it happens that there are no user or far less traffic to our application, of course, would be wasting our resources. So we would want to, of course, manage this with load balancing, right? And then, of course, the server somehow has to know if the load balancer more or less has to know, of course, if the server is alive or not before it can forward requests to it. And most cloud providers, for example, achieve this via health checks. So more or less, the server is supposed to expose an endpoint. The load balancer more or less pings this server via this endpoint. It doesn't have to return any payload, but more or less, if it returns the status 200, for example, then the load balancer knows that this server is alive and knows, of course, forward requests to it when they come in. And if it's not alive, then of course it deregisters it and knows not to forward requests to it. So we'd try to understand the load balancing, like I said, and then we'll talk about how we could build ours. And we talk about like a couple of algorithms that people have developed over the years. And of course, we'll now implement ours, test it out, and see if actually everything works as we expected. So I'm just going to come over here. I will create a README, and then we can more or less use this to track what we would do today. So we talked a little bit about introduction to load balancing. What we could talk about, of course, is how we could design ours. To do this, we need to talk about algorithms for load balancing. And of course, we would again go into our implementation. And of course, in the end, we'll test this out to see if it actually behaves as we would expect. So we would just jump right into design. And then, of course, we would add more flesh as we proceed. And maybe what I can also do is maybe come down here, and then before implementation, we can talk a little bit about how we'd set up our own, how we'd have our own setup, and then just to more or less help us understand what we're doing as we do it. Yeah, so design wise, what we will do more or less, we will not, of course, implement like a industry wide kind of like something you could already maybe use and replace, of course, industry standard load balancers. But the point, of course, is that we would implement something that we can actually test out. We're not going to pay too much attention about it because it's load balancing actually a really complex topic, and it's, trust me, not something one person has developed or did develop in the past. So, but for our own use case, we would have a fleet of servers. And to make this a lot easier, I would assume we actually just have two servers just to make things simple. So like I said, we're simply just going to have two servers. Feel free to add more if you want, and that's also totally fine. Actually, we could make it three. That's should not be a problem. And we would, of course, have a struct that's going to define a server for us. So it's going to have like an address, a weight, and then connections. So we'd want to be able to track the number of connections every server has at every point in time. And so this for this would of course need to create a server pool, which would be like a map more or less of our servers. Um, so, but other than this would of course help us to, so would basically use the sync, would more or less use the sync package from Go. So, so the point would be that we'll try to more or less have a mutex around our servers. That's really what I will try to do here. And then for our server pool, we'll just implement a couple of receiver functions. So we should be able to add server, we should be able to remove server, and we should of course be able to get servers, more or less to get all the servers we have in our server pool. And apart from this, I think that's just all we need to implement our server and our server pool. And other than that, we simply just implement our algorithms. So for the algorithms, there are basically actually three, and but I will of course only talk about one for our example. So that is, of course, you might have already heard about this round robin. There is list connection. It means what it actually sounds like. And then there is, of course, IP hash, which of course means exactly what it sounds like. So we'll talk a little bit about round robin. So for the round robin algorithm, so more or less what this does is it's tries to distribute requests sequentially across your list of servers. And basically it cycles through the lists and then assigns each new request to like your next server in the list. So it's pretty straightforward, pretty simple to implement. It tries to, of course, achieve an even distribution of incoming load across your servers. But the only down part is that it does not already consider, or it doesn't consider the load, the current load or the connections that each of the servers has. So it simply gets 10 incoming requests, and then you have five servers, and then it distributes to each of them two requests each, regardless of if there are already servers in your fleet that are busy. And of course, with list connection, like I said, it sounds like what the name actually connotes. So it assigns each new request to your server from your fewer active connection, your servers with the fewer active connections. So it considers the amount of connections each of your servers already has, and then tries to consider which load each server should get. And so basically, the hash algorithm more or less is a hash function. Um, it uses a hash function more or less to map client IPs to specific servers. So more or less what this does is it tries to ensure that the requests from the same client are always directed to the same server. And of course, you can already imagine this could be beneficial for session persistence and caching and stuff like that. But of course, you can also already imagine that this will not really guarantee even distribution of load. Those are some of the I think these are mostly the mostly prevalent algorithms I want to talk to you about. But I think for our own case, I think what would make more sense for us would be the least connection algorithm, and that's basically what we're going to implement today. So I'm just going to go right ahead, and then we'll start implementation. Enough talks already. So what we can really do is we come in here, and I'll create a folder here. I can call this server one. Like this. And maybe I create a new one. I call this server 2. And let's just make it interesting. You can have 3 servers, more or less. And that's our server 3. So this part is actually pretty straightforward, as you can already imagine. There's really not much going on here. And what I can simply do is I can cd into server 1 just to implement the logic that needs to go in there. And now I can say go mod init. I can simply call it server 1. That's totally fine. We're actually not going to be doing much in here. So we have our mod file, and I can create our main file main.go. It's going to be pretty straightforward. So package main. And what we want to now do more or less is implement our main method, and then we simply just copy it to all our servers, and then we are done with our servers. The most interesting part, of course, would be to implement our load balancer. But anyways, so what I would create here, I'm simply just going to use the net HTTP package in Go. I'm not using any framework because that's really not the point of this video. So let's say I can call this home handler. So more or less, would just expose one endpoint, and then we would use this handler, just in singular handler, to handle every incoming request to that endpoint. That's all we'll be doing. So HTTP dot response writer, and of course request would be a pointer to HTTP dot request. And we implement the body. It's really going to be straightforward. So I'm just going to do io.write string. Come on, help me out here. io.write string. Thank you. And of course, I need to just pass this guy, and then maybe I pass some string, and I say maybe hello world, and then I try to print this into a new line. And maybe what I can also do is to add some login so we can differentiate from which server our log is coming from. So I'm just going to use the log function in Go to keep it simple. So I can call this L, and then this should be log.new. Thank you. And I need my std out. Come on, help me out here. Thank you. And then I need to add some fancy string in here. Maybe I add some square brackets, I don't know. And I give it a name. I call this server 1 like this. And maybe now I just add some dates like this. And what else? Maybe I also add some time. I think this should be fine. Time like this. And now what I can simply do is I come down here and I say l.print f. And then I simply just pass a string and I say run, and I don't know, something like this. We just add some dot 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 like this. And I think we are done with our handler. That's it. And now let's just quickly implement the handler. Pretty straightforward. So we use http dot handle func. And of course, like I said, we just expose one endpoint, which should be the root, and we add our home, not homelander, home handler. And of course, maybe I just throw in here some message print line. And initially, I'm just gonna say maybe something like starting server one dot dot dot, and I'm gonna run this at maybe I say at port 8081. So this is where our first server would be running. And now down here, I just do a log.fatal. Come on, log.fatal. And then in here, I call my listener serve. Listener serve, we are not serving LTTS today. And of course, I need to be consistent. So 8081. And I'm just going to pass nil. So the handler should be fine like this. So more or less, we are done with our first server. That's all the code we'll need actually. And what I can simply do is to copy everything. I think this should be fine because in here you can do go run main.go, and our server should be over at port 1. If you doubt me, we can open a new tab and curl localhost 8081. What did we do? Of course, 8081. Come on, Tony. And of course, we get hello world back. So everything is working as expected. Let's close that up and close this one as well. And so now I can simply come out of here and go into server 2. So go mod init server 2. And I go into server 2 and I create a new file and I call this main.go, and I simply copy this and paste it in here. I don't care, I don't want to repeat myself, and just change some things. So this will be server 2, this will be running at port 8082, 8082, and of course we need to change this to 2 so we are sure. And then of course we copy everything again and then go inside of let's come back again, and now we go into server 3 and we do exactly the same. Go mod init server 3, and in here we'll just again create our main.go, and of course we change this to 3, and then this would run at 8083. This would also run at 8083, and we rename this to 3. And we are actually done with our servers. We don't care about our servers, we only care about our load balancer. It doesn't have to do much here. I'll leave that to you to play around, but that's really not my concern. So now we are done with our servers, and now I'm just going to come in here and create a new file. This will be our main.go. This will actually contain all our logic, more or less, for our load balance. So I come out here and I can do go mod init. I just simply call this, okay, maybe I'll be professional a little bit, Tony. So Basilica and load balancer, and now do go, of course, package man, and now we can actually start our implementation, which of course would be the interesting part. So let's go. So like I told you, I would like to create 2 structs. So one would define our server, and the next would define our server pool. And this of course is really going to be pretty straightforward. So I call this servers. It's going to be, like I told you, I'm going to use sync map like this. And so in here, our server, like I said, would have just few attributes. We don't want to go all crazy here. We just want to focus on implement our simple list connection algorithm for our load balancer, and that's it. That's all we want to do here. So I provide an address. This address is going to be a string. So this is how our load balancer is going to, the address to those our servers we created over here, server 1, 2, and 3. Those are the addresses we're talking about here. Nothing fancy, because it needs to know where to direct the request to. So I add a wait. I'm not sure what you, let's just keep going. And I have connections, and this would be in 64. For now, I'm just going to make it simple like this. And like I said, I would like to implement some receiver functions on our server pool. So func sp for server pool, and I need to implement add server. It should take an address of type string and take a weight of int. Let's see. So this would be this. And of course, I would need to add another method called, let's say, like I said, remove server, and maybe another one called get servers. That's mostly what I want. And now let's go in and fill in the logic. So for add server, again, we're gonna really keep it simple. So we go through our servers and we simply call the start function. We provide the address, and now we of course need to add a semblance of our server, more or less a type that's going to hold our server, and then we simply fill in the attributes, say ADR, that would be the address, and weight, of course, would be weight, like this. Guys, that's all. That's really all we want to do here for now. And of course, for remove, is also going to be pretty straightforward. So I call servers, and I call the delete method, and I provide a key. In this case, the key is going to be our address. That's really all. And then to get our servers, as you can already imagine, this is pretty straightforward. We are not done anything so complex here. So to get servers, of course, we need to return a slice of servers. So, and to do that, what I'm probably going to do is more or less to make an empty slice first, because it might also happen that we don't have any servers live that are live, more or less, or that are ready to receive requests. So that's really it. So now we need to look through our our servers, and I need to provide a function, as you can also look over here. And this function is basically what we're going to do to more or less get our servers, append them into this empty slice that we created over here, and then we return it to fulfill the requirements of this function. Pretty straightforward. So I provide a function like this, and so it should take a key and a value. So I'm just going to make this interface. I'm going to make this an interface. And so let's go in here. So what I would need to do is more or less servers. I call the one above, and of course I do an append, as you can already imagine, and then I just simply provide the value. But of course I need to more or less type this, so I'm just gonna provide server this way. And actually I don't think I need the key, and this would be the callback, of course, and I can simply return true if everything goes well until this point. And then down here we simply return our servers. That's it, and we are done with the methods we wanted to implement on our server pool. So now the interesting thing we want to do more or less would be to implement our list connections, algorithm. And this is going to be pretty straightforward. Trust me, before you close your eyes and open them, we are done. So I call this lists connections, if I can spell. And this is going to take a slice of servers, and I'm just going to pass by reference this way, and it should also return. It takes a slice and it returns one server. Yep, that's what we're gonna do. And now I would like to create a variable that would tell us the best server to serve our request. So I'm simply gonna call this best server, and it's gonna be, of course, the type will be of type server. And I also need to create another variable. I can call this list cons for list connections. And what can I do to this? A second. So maybe what I can actually do is to, I need to find a way that's no matter what we do, would never be able to assign a wrong value. So maybe what I can do is to do a bit shift for in 64 to more or less get like the maximum value we could ever store in 64. So that would never be wrong. So I can do something like this in 64, and I do a bit shift like this. Should be using less than sign. Of course, we use 63 and I subtract by 1. And this should, of course, give me the possible max value I could ever get with this. But anyways, what I would want to do now more or less is to loop through our servers. And now we'll range over our servers, of course. And why are you complaining? No new variables. Are you, of course, Tony? That's bad. And so what we want to do now is we'll simply check the connections of the server. So we say if the server dot connections, if it is less than our list cons, like this, we more or less will term this our best server, and the list connection will simply update it. So we list connections becomes the connection of the server. Like this, that's really all we have to do, trust me. And then what do we do here? Of course, we return our best server. That's really all we have to do to implement our list connection logic. That's really more or less it. So what we would more or less do now is I'll also like to implement a health check, which is simply just going to ping our server, return a response for us to tell us if it is alive or not. And then of course the last part would be to serve, because again this in the end would be a server of its own. So we'd then implement the logic that gets the incoming payload, use the list connection logic to determine the best server to serve the request, and of course forward this in the end to that server. So that's just what we're going to do next. So now let's implement our health check. Again, this is pretty straightforward. Go 101, I would say. This should not be actually the bane of what we would want to do to this, so we'll simply just show this anyways. So but what our health check would do more or less would be to make an HTTP get to a given server. That's really it. So we need to have a function that takes server as an input and returns a boolean. So if the ping is successful, it returns true, of course, and false otherwise. So we need to do a URL parse first. I would like to pass the URL first just to be sure, and then I would of course make this. Now I'm working locally, of course, so I'm gonna go with HTTP. This should be totally fine. And now I need to just pass my address from the server. So that way, this is just going to take care of, I don't have to worry about if I had this in the first place or not, whatever. I don't have to worry about this. So the person will take care of it for me anyways. And it returns two things, a URL and an error. So we can, of course, handle that. So we have URL, error. And you can already guess, we have to undo the error. Of course, if this error is not nil, we return false. This is already a failure for us. Anyways, if everything is fine until this point, I would like to, of course, create an HTTP client. So this is pretty straightforward. So I use the HTTP client like this, and then I provide, I simply provide a simple timeout. This is going to be 5 seconds. So this will be 5 times second like this. That's our client. And now we simply do a get. So client.get, and we provide our URL. Of course, we need the string attribute of it. And of course, this should return two things again, as you can imagine. So we have here response and error. Again, I'm just going to copy this guy, bring it down here. So if we have an error, of course, we return false. That should be it. And then I'm going to defer closing this response body. So body.close. And now what I can do here is more or less to focus on the status code. I'm going to make sure, of course, that all our servers return the status 200. Okay. So now here I return the response.status code, and it needs to be equal to our http.status okay, like this. So this is just one easy way of saying if this equal to this, return true, otherwise false. So we can do all of this with a one liner. That's totally fine. And so that's really all we have to do. Let's just make sure that we are returning the status 200. And yeah, this should be fine. This should be fine. Okay. So we've implemented our health check. So now I need to implement a function that's going to help me actually run this health check. So I can call this run health check, and it's going to take our reference to our server pool, and I would also like to more or less control the interval of these checks, because also if you work with the cloud, let's say with Azure, you get of course to modify, configure how much, if you're, let's say, using like an application load balancer and you would want to constantly of course ping your application to check if you're live or not, you also get to provide the interval. So here I would also like to provide an interval. It's going to be of type duration. I don't want to constantly ping my server and then bore them out. That would be super annoying. And the first thing I would like to do more or less here is to sleep for this interval. And when I've slept, sorry, and woken up, I would like to loop through my servers. Of course, I use the range again like we did before, and then I need to again provide a function like this. And so I can call this key value. Again, I'm gonna make this interface. So let's see, and then I can decide on what to call them appropriately. So I'll do let's say healthy, and this would be me actually running the health check. So here I provide a server, and of course I need to type it. So server like this. And now I can actually maybe change this to address, come on. And this would be server like this. And now we simply say if not healthy. So what I'm gonna do more or less is if it's not healthy, I'm simply just gonna remove that server by providing the address. I'm like this. And of course, again, I need to type it like this again. But the points would be, of course, for our own use case, it might not really, we get an error here. 1 second, let me see. This, do we have a wait? Let me see. Oh, my bad. Of course, this was never used here. Oh, let me see. This is also not used here. So I best remove this from here. My bad. Um, okay. So, like I was saying, so what I'm doing here, as you could see, is if this is not healthy, I pop this from my server pool. Again, this is not how actual load balancers work, because you don't want to, of course, again, like I said, it's much more complex. So it's not, anyways, the load balance is not anyway storing the address pool or the server pool in memory. Of course, this is stored somewhere, somehow within the application itself, the load balancer. So, but our own case, of course, we are storing this in memory. But again, the problem with popping this way would be, of course, if it eventually becomes healthy, or if it eventually comes back online, we don't have that address pool anymore. So maybe what you could also do just to have fun maybe is to have another way to kind of like maybe pop it from the healthy list. Maybe you have to list healthy and unhealthy ones. You pop it from the healthy list and put it in an unhealthy one. And then maybe for the unhealthy one, you kind of like check their health, maybe let's say once every 5 minutes. I don't know, whatever you decide. And then if it's healthy, you put it back into the pool. And you could use channels like I've shown you in this tutorial. There are so many. This is can really be fun, but I really want you to experiment this on your own and have fun in the process. Just do whatever you want to do. Share with me what your outcomes are. Anyways, at this point, I'll simply return true after I've run my check. So that should be it for now. So now let's actually go to the main thing, and this would be our load balancer. It's going to be pretty straightforward. So for our load balancer, I would create a struct. I'll call this load balancer, of course. Which better name to give it? What better name to give it? So I need a server pool, which of course we already have over here. I need an algorithm, which is basically gonna have this signature here. Like, where is our algorithm? This one is this one. So I'm simply just gonna copy this next. So basically for now, anything that has this signature would be our algorithm. That's that's really what we're doing. We're keeping it simple, guys. And now I need a health check. Maybe I'll just simply call it interval. And again, it's going to be of type duration, like we already did before. And now I need to actually implement two methods, one method actually. So one would be, and that method will be simply be that's the method that's going to serve our HTTP. So I need to create a receiver function on our load balancer struct. So this would be load balancer. And like I said, I'm just going to call this serve HTTP like this. It's still going to have the same signature as our regular function when we try to create a handler for our request. So it's gonna I'm gonna provide here response writer, and of course our pointer to, of course, our request. I can say call this rec like this. And now, of course, it's not going to return anything anyways. It's simply just going to serve our HTTP server for our load balancer. So our servers, I simply get this from our server pool lb dot common server pool, and I call the get servers method. And let's look at our get servers method. Of course, this was not needed. This is why you should not do copy and paste, guys. It's bad. It can mess you up. And anyways, what I would want to do, of course, would be to check the length of the servers that we returned. If nothing was returned, there's really no way to proceed at this point. So I'm just going to do an HTTP error here. I'll do a HTTP error. I provide my response writer, and then I provide a string, and I can see something like there are no servers available, like this. And of course, I need to maybe provide a status code. I need a service unavailable, like this. So if there are no servers, if we can't get any servers, we simply, of course, do this. But if we do, then here I need to create a server. This would be I need my algorithm, and I need to pass my servers like this. So this will, of course, return our a server for us. So, but of course, if you remember, we have this algorithm over here. So this is going to return, in this case, our lists, this guy, list connections algorithm. That's what it's going to return for us for this server. And so, of course, we created our servers as pointers. So we should be able to check if they are nil, if they are nullable. So if it is not equal to right now, if it is actually nil, then I'm also going to do something like this. And of course, I need to remember return just so our code doesn't just keep proceeding after it hits this error. So again, I'm also just going to return like this here. So what I'm going to do more or less is to um, more or less adjust the connection of this server. And of course, in the end, I will also return this to its actual value. So I'm just going to adjust the value by 1. And then in the end, I'm going to return it to its actual value. So I use the atomic package in Go. And then I need to add, because my type was 64. Again, there are a couple of things you have to pay attention because it's again specific to yeah, you can also see it over here. So if you target 32-bit platforms, there is a bug, but that's not the case for me. But of course, it's good to know that this would be what that you could run into a problem if you're running this on a 32-bit system, just in case you start wondering if something went wrong. Anyways, I need to provide a pointer to what I want to adjust. So I'm going to adjust the server connections, and I'm going to adjust this by 1. And of course, in the end, I'm just going to do the exact same thing and return it back to its actual value. So I'm just going to copy this guy, and down here, I'll defer this, and then I change this to -1. And now, so what I would simply want to do more or less is now take care of our serving of HTTP, and then that's it, we're done. So the last thing, of course, would be to use a reverse proxy to then forward the request to where we want it to. So I can use the HTTP utils, help me here, package, and then I use the new single, this one. And of course, I need to provide the URL. And in here, of course, I can now provide scheme. Come on. Since we are running this on localhost, so our scheme is just going to be HTTP, and the host would be, of course, our server address like this. And now when we have this, we simply, of course, this returns a proxy. If I hover over this, you also see it returns a reverse proxy, and I simply just call it a proxy. So with our proxy, we now serve our request. So proxy.serve HTTP, and then provide our response writer and our requests like this. And that's mostly it. And I think that's mostly what I would want to do. I'm probably also going to add some metrics, but I think that's, of course, it's not going to affect what we're doing. So now we'll bring it all together. So I create a main function over here, and it's going to be pretty straightforward, guys. So I have a server pool. I create a server pool, and of course, I'm going to create instantiate it this way. So we have a server pool like this, and the algorithm that I'll be using would be my list connections. I don't want to invoke it, and I need my interval. So my interval would be let's make it 5 seconds. Come on, let's make it 5 seconds. Our interval would be 5 seconds, and I need to add some address pool to address it to our address pool more or less. So now I can provide so I need to use my server pool this way and call the add method that we created, and I need to provide an address, and I give it a weight. So I'm just going to give this one 1. So but what I would put here would, of course, would be the address of the servers we created initially. So this would be HTTP or maybe I'll keep it simple. I say 127 because again I remember what I did with the URL parsing, so that's totally fine. 0.0.1, and the first one was at 8081. And I'm just gonna copy this a couple of times, actually 3 times. So this would be 2, and this would be 3. And of course, this would be 2 again, and this would be 3. So we have all our servers and we've added them. And I need to create a load balancer like this. come on, help me here. Load balancer like this, and then my server pool, of course, would be server pool like this, and algorithm would be algorithm, and interval would be, come on, interval would be interval like this. And now we have our load balancer. And what I would want to do more or less is to use Go routine to run our health check in the background. So I say run health check. I provide my server pool like this, and I provide the interval. And that's really all we want to do. And then in the end, of course, we need to now serve our requests. So I say HTTP handle. I provide, of course, I'm going to, for now, we will allow an incoming request, of course, to the root, and then we forward this our load balancer like this. Pretty straightforward, guys. And now I'll just want to put some messages down here. So I do something like print, come on, print line, and then we'll just so we know when something is happening. And we can say starting load balancer server at port. So this is going to run at 8080. And of course, we now have to start our server. So again, I do a log.federal, and in here, we do a http.listing and serve. And again, we said it's going to run at port 8080, and it's going to now have in the handler for handler, just going to provide new. And really, that's basically all we want to do. I'm just going to shut this down. And so we can take a look. So if you look in our main method, it's pretty straightforward. Again, we could add some metrics. I already did. I did this, of course, and I can also share this with you if you're interested. But of course, that does not in any way affect what we want to do, which is, of course, load balancing. So we have this here. And now what I would want to do in the end would be to maybe create a new folder. I call this client. And so I'll cd into client. So what I want to do here is to create a client that's going to infinitely forward requests to our load balancer server, and then we see how it distributes requests to our load balance, our servers, our fleet of servers. That in this case, of course, are just 3. So that's that's really what we want to do here. And of course, it's really going to be pretty straightforward. I'm just going to actually come over here and copy this health check. I don't care. I don't want to repeat myself. And then in here, I do a go mod init, and I call this client like this. And I can touch amen.go, of course. And then inside here, package main, and I provide this health check here. And of course, I need to provide a main method so we can handle all of this. And our head check is going to simply just gonna, we don't care, simply just gonna take an address, which is gonna be a string. That's really all it's gonna do. It's gonna take an address, and then the rest is gonna continue. So here will just be address. That's totally fine. I don't want to make this complicated. You don't have to. There's really no point. And now we can maybe say maybe what I can do here to track the number of requests we are making. I can create one here, a value here, and I just call this 1. And now I create my infinite loop. So we would infinitely make requests to our load balancer server and then watch it distribute the requests. That's what I want to do. So print line, and I can say serving, I say total number of requests served. And I can, either way, I don't want to format it. I don't want to waste my time anyway. So like this. And we now do a health check. Simply call our health check. And I'm just going to provide this localhost 8080. Remember, the incoming request comes into our load balancer server, and then the load balancer server takes care of the distribution under the hood. We don't want to concern ourselves with all of that. Anyway, and here I simply increase our num like this, so that's totally fine. And of course, in the end, I think we are done. And maybe what I can do is, of course, make this a little bit smaller so we can have a lot more room so you can see what we are doing. And so now I can, of course, claim my tab. I can split my screen this way and maybe even split it further, and maybe, of course, split it even further. Yeah, I have to, I can. So now let's go into server one and we run our server main.go. And now I can actually pull this up. So you see this is actually running at port 8081. And we go into server 2. And again, we run main.go. And this should, of course, run at 8082. And of course, we go into our third server. And again, go run main.go. And this is up. So now what we can simply do is maybe run our main server, go run main, and then watch what happens. Let's see if we run into some errors. So it is up. And now let's see if it actually makes, so now we see it's actually pinging our servers. So it's doing the health checks, as you can see over here. And that's totally fine. So maybe, of course, to now test it out, we would maybe open a client and then watch all of this together and see if it's actually doing exactly what we want it to do. So if you look over here, you would see that, of course, we are still serving our requests. It's still pinging our servers, as you can see. And now what I can do maybe would be to bring this over here. And now I cd into load balancer. And then here, of course, I should see our client. So I go into clients. And now let's run our client. And now you see, of course, this is forwarding the request to this guy. And then this guy is then, of course, distributing the request to our three servers over here. If I terminate, if you look over here, of course, you can see the number of requests being served. If I cancel this, everything stops again. But the cool thing, as you can already see here, is that no one server is allowed or handles all our requests. If I make a simple curl here, so let's make a simple curl to localhost 8080. One of them simply handles the request, right? So if you doubt me, we can maybe go into each of them. So let's go into server one. So let's say hello world from server one, for example, and then we go to server two and we simply do the same. Server two. And now let's go to server 3 and then we also do the same hello world server 3 like this. And now what we can do, of course, is I will stop the load balancer server and I stop each of these servers like this. So let's start this guy and let's start this guy as well. So and now let's start this one and then we watch it ping our servers. And let's give it a couple of fives. Now we see it pings all the servers as before. And now let's make the curl again. And now we get a request from server 2. Now we get from 1, from 1, from 2, from 1, from 2, from 3. You see here, like, no, we don't get the same request from one particular server. It's really completely distributed. And again, we can, of course, run our clients this way. And then it again should be able to distribute our request. Again, I am not doing this so we replace this with like industry standard load balancers, but I just felt it made sense that if that's we know about load balancers, we have an idea of how it works, and then we can maybe, like I said, begin to appreciate the work that system developers, system engineers actually do. Anyways, guys, that's all I wanted to show you in this video. Stay learning and of course keep following us. Subscribe, of course, if you're new. I try to bring to you quite interesting topics, and there's always something for everyone to learn. Feel free to leave your comments, leave your questions if you have any, and I will respond. I always respond. I try to do that actually, so I will always respond as fast as I can. And yeah, guys, that will be all for today. Until next time, have a lovely evening. Stay positive, stay hungry for knowledge, and yeah, bye bye.